Okay. Next topic. Next topic is rules for block diagram reduction. That is our next topic is block diagram reduction. We are having 11 rules for block diagram reduction. So you can see in this slide there is rule number one, which having a combining blocks in series or cascade, so that if the system are connected in series, that is G1 and G2. So if you want to combining those blocks, it will be combined by the multiplication. You can see in the diagram. Next, rule number two, the combining blocks in parallel. So if there is a block in parallel and having a summing as a connecting point, so that you can go for an additional process by combining the blocks in parallel. For rule number three, we are having a moving take of that is a branch point ahead of the block, so that uh, moving the take of that is a branch point the head of the block. You have to move the branch point from here to here. But if you are connecting the branch point to here, you will get a G as an addition value. So if you want to reduce the G, you have to divide it. So that we are adding the block by dividing option. So you can see in the diagram. Next, rule number four, that is a moving take off branch point beyond the block. That is, you can see in the diagram here, we are having a branch point which we need to move to the front side of the system. So if you are connecting the branch point front of the system, we will miss the G. So for having the G, we have to multiply the G, or we have to add the G in the system. So rule number five is the moving the summing point head of the block. That means we have to move the summing point, that is uh, from the front portion of the system to the next of the system. So if you are moving the summing point from the front portion of the system to the next of the system, so G will be added with B and A. So we will miss it. So we have to put the G for individual A and B. You can see in the diagram they have added the G for individual system. So in the rule number six, we have to moving the summing point beyond the block. So already we are having the summing point after the block. We have to move it back, so that if we are moving it back, we will miss the G for A. So we will miss the we will have the addition of G for B. So we have to divide it by G. So you can see having a rule number seven, that is the interchanging the summing point. We have to interchange the summing point. Now, while doing this, we have to look after whether the sign are same. That is for A, B, and C, whether they are having a positive or negative. That should be replaced as the same notation. So that we have to look after, and just like that, we can switch the summing points. Next, for splitting the summing points, you can see here the same rule, that is we have to note down the notations, that is the positive or positive or negative. We should give their sign as same as that. We should not change it. So you can see we have splitted the summing point. How but the reverse works, that is if we are combining the summing point, the same sign should be given here, and we can combine it as a single summing point. Next, the rule number 10, that is the important rule in the negative in the block diagram reduction, that is the eliminating the negative feedback. You can see in the diagram we are going to reduce the entire block into a single block system. You can see here we have to reduce the entire block into a single block system. You can see we have the input as R and output as C, and the system is G, and the feedback is H. So if you want to find out the that is the output, that is output is equal to R minus CH into G. So as everybody know, the efficiency of the machine or a system, whatever it may, that is output by input. So C by R. So at the final, we need to find out the C by R. The output is nothing but output C is equal to R minus CH into G. So you are substituting the G, you will get RG minus CHG. You are moving the C values one side. So the minus CH will be moved to the left hand side, so you will get C plus CHG, that is equal to RG. When you are taking the C as a common, you will get 1 plus HG, that is equal to RG. So C by R is equal to, that is the our efficiency. So the R, you have to put the R here, and you have going to cross multiply. So G will remain here itself. When you are cross multiplying it, you will get 1 plus GH. That is G divided. So that is the formula for negative feedback system. If you are eliminating the positive feedback, nothing but the sign will be changed. That's it. Okay. So we can go for a problem. That is, if you are obtaining the transfer function of the block diagram, you can see the block diagram. We don't know where we have to start. So it is very simply, you can start with G1, G2 cascade. So just like that, you will cascade the G1 and G2. So what will the next stage? So next stage, we can combine the G3 and the G4. So we can split out this point into this side and this side, so that we will have the combining blocks G4 and G4 which are connected in parallel. Here there should be notations. Okay. So we are combining the G3 and G4. So next, we have to reduce the minor feedback. You can see, you can reduce these blocks as a negative feedback. So we can reduce the block into a negative feedback system. So as a rule of negative feedback system, that is C by R is equal to G divided by 1 plus GH. So by uh, next one is, as a cascade process, combining process, we will combine the by using the multiplication. So you can see here we have combined the cascade process until we have one for a positive feedback system. So the final answer of output by input is P of S R of S equal to G1 G2, that is G3 plus G4 divided by 1 plus G1 G2 H1 minus G1 G2 into G2 plus G4 into H2. So this is the feedback system, that is the block diagram reduction system. So we have the different types of block diagram reduction system. And the next is block diagram to signal flow graph. So you can see the block diagram to signal flow graph in the next video. Thank you.